Hello, everybody, and this is Cesar from Blue Beehive, and I will try to explain how to develop the social distance warning device. Focus on the project Discovery STEM. Okay, the first is I will try to make a presentation about what we want to develop, even, and I will try to speak about the elements that we need to develop that. After that, we will go to Thinkercad to try to make the simulation of the elements that we want to develop, and after we will go to Thinkercad again to design the shell of the elements. That's all we want to do during the training of today. Then, first of all, there's a quick overview what we expect related to the demo we want today to want to make. Then let's go first related to the idea. Our main idea is just in COVID time, we want to develop some elements that want to advise us when someone is near us. Very near, it should be depending on 1 meter, 80 centimeters, depending on us, what we want to program in, and we will see. Even in the moment that someone is close to us, the system should start to make a beeper sound to advise us on that. Also, the elements should have three LEDs with green, yellow, and red. Green means that you are safe, red means that you are not safe, and yellow is you are boarded not to be safe. So we will also introduce a LCD element that can advise us with letters about the distance where is the other persons are close to us. For do that, as we will see, is the most take in the head that we will start to work with Arduino Uno, and we will use a sonar element that will provide to us the distance as a impulse, something similar like a radar in the submarines. That is something that launching on the way. And the rule will be if we detect some object less than 50 centimeters, they start to advise us with red LED and with the buzzer, and also some information on the LCD that we will programming on the way. As we was just telling you, how the sonar goes is just launching a wave in one direction and turning back. In the moment that in one of the elements go and back, they detect the distance of the sound, and then we provide how close are the element to us. It's something similar like the bats. Also the bats that that are blind, they use like a system like this to understand where the distance close to objects to avoid it on the fly. Then let's now make a quick overview about the Arduino components that we will use on the way for developing these social distance elements. First of all, for sure, we need an Arduino Uno. They provide some digital pins, analogical pins, also 5 volts, 3.3 volts, and the GND elements. All of they very important for us on the development. The wire to connect the Arduino board to the computer, the breadboard where we jump all the elements. For sure, in the final development, maybe we don't need to use that. We can just so melt the elements one with others. But for the training elements, just to develop in the class, it will be useful to use the breadboard. Then the LEDs, we know LEDs are important, just depending anode, cathode, and as we know, the LEDs working with 3.3 volts. That means if we put by 5 volts, we need to use a resistor close to 220 ohms that help us, support us on the connection not to crash on the development. And also, the most is that we have 220. That means that it should be red, red, and brown. That is should be the resistor we will use. For sure, wires, different kind of wires, male, male, female, female, and male, female. All this should be interesting to use on the development and also with the connections. The buffer, we know buffer there is many different. I don't know where you will have for developing, but the most easiest is just using with two pins, one related to the positive way, the other related to the negative. But normally the positive will go connected with some port of the Arduino to be sure that we can control the sound that we want to launch on the element. Then, whatever you want to use, one or two, with two or three pins, don't mind, because at the end we will use the most on that. Sonar, at the sonar we see that have four different pins, and each of them are important. The BCC is 5 volts, that's normally connected to 5 volts. GND is in the negative way connected with GND, and later we have two that should be elements related to launching the echo wave and when it should be launched. We will use the different ports for that. The LCD, we need to take care on that because LCD I2C port means that is simple way to connect with Arduino. If we don't use the I2C boarding connected with the LCD, means that we will need like 9, 10 wire connections with the Arduino. Then it's important if you try to develop this social distance element, you should use LCD plus the I2C board because as you see is CCS with the I2C in this way is connecting all these pins are connected to the LCD, and from our side we just need four GND, BCC, and after that STA and SCL, and we will use two analogical uh, ports to connect to the Arduino. As you see, that's how Arduino have the pinout of that. I will just not explain too much on that. For our case, what we want, just presenting all the elements, is that we will use the pin digital pin 4 for trigger in sonar, digital 5 pin for echo in sonar. We will use digital 6 for the red light. We will use digital pin 7 for yellow LED, and we will use the digital pin 8 for green. And for using the control of the buzzer to send some elements, we will use the digital pin 9. For the control of the LCD plus I2C board bus, we will use analogical pin 5 for STA, analogical pin 4 for SCL, and the GND and bulk that it will be all complements in all the elements of that. And that is the boarding, how we will wire. That's in this moment, we will go for the Thinkocar web page to develop it on. So it's in Spanish. I will move to English. It will be easiest for all of you to understand what I will do on the element. Then on Tinkercad, when you are logged on the system, you can go to Circuit or just Tinker, Circuit, Development. Those more of Tinkercad. We know the area for 3D design, that is the digital 3D model that we will use after that for the 3D printer, and this is the circuit. Then we will use create circuit simulator. Then actually now it's ready to do that, and we will put here the distance, and after that we will start to put in the board the elements that we will want to use. In this case, the Arduino, the breadboard, then one LED, two LEDs, three LEDs, even resistors, one resistor, 200 ohms, red, brown. Even in this moment, we can make this copy and paste. We want one red, one yellow, and one green. These elements. Green. Now let's go to find the piezo or buzzer. Also the ultrasound element and also the LCD. In my case, I will use LCD plus 2I2C. Should be this. Okay. We can comprove that we are using these four ports on that. The other, as you saw, this is the LCD without the I to C, and this should be, we need to connect with all this. And I don't want this, I will skip all the elements on the way. Then we remember related to the situation that we was explaining on. Then we will put here that okay. Yes, we will put the LEDs. LED here, one LED. Resistor. In this way, we will rotate resistor. In this position, I prefer. Okay. Okay. Yeah, we see the cathode, the anode to the resistor. The cathode, sorry, that is not good. This is not correct. Better. Positive, negative, positive, negative. Okay, perfect on that. We know all these are always connected. Then actually now we will use the black one to connect from here to negative. We will use the negative. We will use to the negative. So we will use the color to go to positive and go to positive. And that is one of the elements we're going to do. We have the buffer. Also here, here. The buzzer I will use in this position, also here in this, because it will be simple for us. The positive, the positive should go to the Arduino board. Negative, go to the GND, go to GND, and 5 volts, go to 5 volts. I don't want this. Let's go for one. This have 4 pins. This is the board we will use, not this. 5 volts, 5 volts, GND. That should be in black. We have here the Arduino board. CD. GND goes to GND. 5 volts. In 5 volts. Also, the most important is that 5 volts will connect with positive way, and GND will connect with GND. With this situation that we have now, GND black goes to put on the 3 LEDs on the pulsar on the ultrasonic element and also in the LCD. And with the 5 volts, we make the same. We go to the positive, we put on direct on the anode, cathode off all the LEDs. Also goes to the poles and also here. As you remember, in the buzzer, we just need to connect the buzzer to the correct port we have here. Remember, if we go here, that buzzer will be digital pin 9. Digital pin 9 means buzzer. I will use, for example, the green to be sure that it will go to the digital 9. Okay, buzzer now is connected to digital 9. We go now to see the other for sure. The pins are not connected with this, sorry, because we want the control of the LEDs directly to the Arduino. That means that red in digital 6, yellow in 7, and green in 8. 6, 7, and 8. That means this pin go to 6. This pin goes to 7. And this pin goes to 8. Perfectly. Then we need to go for the ultrasound sonar digital trigger on digital 4 and echo on digital 5. Trigger, we know here, trigger goes to digital 4. I will change the color of that. Let's put pink. Go for digital 4 and echo can go on digital 5. Okay, we have it now. And the last two, it will be in analogic port. It's important to take it in account. SDA5, SCL4. SDL, SDA. I will change the color again. Maybe we can use the brown. This will be 4 going to 4, 4. Mhm. And this goes for 5. And that's all. With this, we have all created on Tinkercad. That is the element we have. If we go to the emulation, it's just to have. And nothing is broken and all is going well. It's not doing nothing more because it's not coding what we want to do with elements. We should go to coding here. But that is other way because at the end it's just coding here is using the same that we will use on the M block elements. Okay, that's for we will go directly to M block. That it will be easiest. And that's what I have here. And this we can see what we want to do with the Arduino board with the social distance element. Most we have to take in account when we are using that or developing is what we want to do. First should be that we want to put on the LCD in the memory slot that we have the two lines and we need to set it. We need to clear. And after that, we need to create hello, welcome to social distance. The minimum distance should be 30 centimeters. I put 30, should be 50, whatever we want to use. It's very simple to use only with the drag and drop elements that we have using on M-block as we saw already. Normally, all the elements related to Arduino are here in the area of robotics. When we go here, we have all the elements related to that. And the functionality we want to use on the elements is always the same. It's at the end is using a circle uh, forever control element where we want that reading the tree coming from pin 4 and the echo coming for pin 5 that we was defining. First is just cleaning whatever it will be in the screen. And if the distance is under 30, under 50, it's just play a tone on the buzzer, set the, depending on the pin we want, set the digital pin 6 or digital pin 8, turn on the lights, starting to write on the LCD element, and after this, just writing, warning, the distance is to keep distance. In any other case, we can just use clean and say you are in the safe distance. So we are here just introducing those two elements, that is red and green. If we want to introduce the yellow light even here, it's just adding a new one, conditional between different points where you will say, if you are between this and this, in yellow. If you are between this and this, it's red. If you are between this and this, it's green. Let's say that is the most important coding that we need to define into the application on the element of the configuration. After, let's say, this kind of use of Syncrocard and also the simulator, I will want to introduce you the same that we did, but directly on the Arduino board and just directly jumping the correct elements. First of all, as usual, when I make it on Tinkercad, I pick up the board, I put the GND and 5 volts. The red wire is 5 volts, the black wire is GND, and go directly to the breadboard to jump the both on the bread, the yellow one and the second is just to put the traffic lights. In my case, I use this element that is better than using only LEDs because the resistors are included on the element. Then as you see here, it's just red, yellow, green, and they only use the pin of the GND and the pin of each of the red, yellow, and green lights. And from the green goes to 8, from the yellow go to 7, and the red go to 6, as we have previously. And it's the right. Then it's jumping, let jumping the board, and the element is connected and ready to use on the coding. For the buffer that we say have only two wires, it should be the same. The negative should be connected to the negative line we have here, and the positive will go to the pin 9 as we was just speaking. Pin 9, that is this wire is going to the element. We go to the radar of ultrasound element device. It was important to remember that you should use the XCSR04 or one different branch, but we will have 4 pins. BCC, GND, trigger, and echo elements because it's so simple to use that on the M block coding. Then with the jumping, it should be the same. We can see that the BCC, this the red one, is coming to the red line. The black one is coming to the black wire, and the yellow and blue are connected with the pin 4 for trigger and blue for the echo. And now we go for the LCD. For the LCD, as I was explaining previously, that you see that in this case I'm using the I2C. And this is very important because I don't need to wire 16 pin. I will only need to wire 4. The black goes to the breadboard in the negative. The red goes to the positive in the breadboard, and I use the SDA connected with the A5. You see the orange wire, and the brown one that is the LCL, that is like the clock, counting clock, is going to the A4 analogical ports. With this, let's say that we are totally setting up the device using the element, and that is how it could be. I hope you can have it better than me, but at the end you see all the elements wired correctly on the Arduino board, even with the breadboard, and even using the LCD, the buffer, the traffic lights, and the ultrasound. That's all related to the connection of that. And we was watching that using the M block. We see that all the elements are here. Normally, when we go to robot, the most that we need to take in account is that the LCD I2C is not by default in M block. Then we need to go to extension, and we need to add extension. We need to find this library, LCD I2C pack, and later when we have it, that's install. It's most important. We need to go. Sometime we can use also from the GitHub. There is a specific GitHub where we can download the files in zip, and after we download in zip, we can add inside of Arduino and block folder libraries with the liquid crystal I2C. It will be at the end in one way or other way. We will have the Arduino. This is another and block library, also interesting to use with the I2C interface. Plus, the most is in one way or other, we go to manage extension, add extension, setting or selecting the zip that we download. And after that, we are ready to have these elements related to LCD. We go on the beginning, we don't have it here. And after installing the library, we have these elements that we can use as a part of the social distance uh, development. And as I was explaining you directly from MBlock, in this case, I just do it in simple way using only two LEDs, the red and the yellow, because this will be the quicker. The end is that is depending on how far, how close we are receiving the distance from the ultra wide. We will put green or we will put red directly. We are not using the yellow one, but if we want to use yellow one, it's just introducing a new one conditional on that. That part I put you as a implementation from your way to be sure that you understand what I'm doing. Okay, and the last part where we will go back again to Tinkercad, we will try to design 3D element, the shell of the chase of all the social distance to have it in better way that not just only in the breadboard. For that, we need to design by hand. The goal is just to put the Arduino inside of like a box with the ultrasound detector, with the buzzer, with the breadboard, and also the LEDs all together in one box that we can print using 3D printer. Okay, then this in a quick view, that is how we was designing the ultra wide, the speaker booth, the Arduino, and also the three LEDs, traffic lights. Even that after that we can develop the elements for the box of the head that could be the cap of the LCD. Also for that, we preview how to print on the printer, and after this, we have the elements printed. I will maybe show you. Okay, after that is yeah, we can see. I will launch you a video of how it will be going on the demonstration. We can have, in my case, I just jump once I code in, I put a power bank battery with elements with all already ready to use. We can see here the test with the 30 centimeter distance. Actually, I'm just focusing to my wall and telling that is like 42 centimeters distance. When I put my hand, see the tag, that is 15, only 15, 18, and it's starting to beep, beep, make the buffer, make the sound, and just taking in account. Okay, it's really how it's working, and it's really how yours should be work when after you develop the same that I made here. Okay, then the last part of my presentation will go focus to how to quick review or remembering from my side how to design using Tinkercad. Then for that, we go back again to the dashboard on, in my case, Blue Beehive. I will go to create a 3D design. To, to create my box, I will use some STL models pre-designing previously that help me in my case, to be sure that we can have it. Let's say even you can download that directly from the folder on the pilot we have. The most is I will first introduce the Arduino file. I have here one file with the Arduino board. I will import and after, okay, sorry. That it will be just ready to have it. I, I already prepared for all of you that it will be how it will be used. It's the starting point to have the box with all the elements that you can just directly put here. I used previously 3D Arduino to put here and to be sure that you have it. After that, even I can use another 3D model already created from my side. That it will be the traffic light dimensions in my case, because I want to use it on as an element. That is one element related to traffic lights. And another element that I have already prepared design it is the LCD box. With these three, it will be easy to start to create something. Okay, that is. I already prepared using Tinkercad because it will be easy for you to work with this. You remember that using the Tinkercad to design is something just you create a box. I will do, for example, and I can modify the elements of the box just using, as you remember, when we was in Spain, you was in Spain, we was just working with this. different elements. I can move the size. I can change directly right in here. I want just 15. I wish in this case it should be 100. In my case here it should be 100. That's the way how I can just create in elements one by one. If I want another wall, I can create one box more. I can put in the top of this. In the same way, I can say 100. I can move to pigs. Even this wall, it should be maybe only 5. The way that I can start to create my elements depending on where I want to do. In all the moments, I can use the arrows to help me on the way to be sure that I can put it easiest on the connection between the elements. In this case, for example, okay, the other position should be the same. Copy paste. You can make copy paste all the time I want to use it. Make the boxes. You can see how easy I can do it. After that, I can use moving different elements. Even if I use this element with this element, I might join together these elements. I can go here to shape that in only one element. See, in this case, remember on that. Okay, in my case, what I will do is I will try to do something different. You can see I have this element, but I want to rotate. Okay, I will want to put into this chase. For example, just using this part and using something like this. I want to put the elements in the size. Mhm. In my case, if I make this element as a whole, you see, that's mean if I join directly, it will make a hole in this wall. Okay, if I make it this way, it can join in both of the positions. Something that I need to think what I want to do with this element inside of this box. Even I will say, okay, I don't want that. Not in 10, maybe I want to have it in 2. Mhm. To integrate in the way that I want to integrate. Huh? That is important because actually now I can make this element um, okay, can move this element. Also, you can use this. You can use the box to use the element, whatever you want to use. In my case, I will just add this element, go into this position, changing number of elements, radio, it should be not 20, could be maybe something like 9. Okay, yes, preferably. I think it's maybe 12. Okay, have it. This should be more or less the size of the hole we want to use. Mhm. Make a copy, paste, and I will move this to this hollow, and paste, and I will move to this hollow. Okay, then most is that, as you know, these elements are transparent, means that if I try to join, it will make the hollows. Then first I will just using these two elements, I will join both. It means that I integrate this position. And even now I will do that. Elements I will join again. And that's why I have the hollows for the traffic lights. In the same way I will do here, depending on the speaker or the booster that you will use. If you should use different elements, I will do this. I will let's think that this is the size, the element I have. For sure, as you should have your different buffer, you need to size to measure the size of the your buzzer, and just here you should change the elements you need on the both directions to make the this cylinder bigger or smaller, that depending on. In my case, I will use that only because I don't want to lose more on this. Put in the size as I check in here. Okay, it will be in this way. The dust is the same, it's transparent. I select both. I go here and I make the hole. Yeah, then actually I have the hole for the buzzer. I make the three for for the uh, for the traffic lights. Even I have here for the Arduino. In this, I will put here the mm, ultrasound element. I can make a plate and just measure the elements on that to have it. In my case, also with this element, is the cover I will use in my topping as a topping of the house. You see, for example, in this case, the element is bigger. In this house, I can just redesign the box to have something that will really go in this way. Okay, something it would be better. In some case, in which take this element, we can have the distance is 86 point, and we can go here and say 86.3. That's how it will go. So that's important to take in the head that we want this element to have it in two different parts. We don't need to join for one issue. And the issue is that we don't want to use, we want to print as a different elements, not as the same element. That's why we will use this to be sure that all is going well, all is connecting, and so maybe we want to be on that. You say why we have this element outside, because maybe we need to put some wires outside, or we can have, and this should be something that will be even easiest to have some put inside hot air outside of the box, because Arduino always hot more than enough. Then that's uh, that's one of the possibilities to develop this house on what we have at the end, the box, the fold. If we want to grade something, it will be easiest to go here to put the element. We can just change the weight, maybe 8. Even as you know, it always is easiest to reduce or have. In this case, I will write here. mm, Yeah, mhm. This distance we can have here different size. 5, I will say 12 millimeters. I don't want more. And after that, even I can put these elements inside of. Ready to. I will even join. It's important when you try to join not to select all the elements, just the element you need to join. In my case, it's these two elements. You go here, and actually now I have all ready to print. Go here, actually to the box and also the shell. Let's now go to the 3D printer to print the element and to have the final version of these elements ready to print. Then next should be just to export and will be I will change the name. Is that always a name? Social distance. Sure. Okay, then I select this element. I go to export. I go to STL. Prepare in model and download it. And I will select. I will go for. We'll go to the social distance self element. And here I will open. And that is the file in 3D ready to download. These are files and elements. You can change different positions on that. And now we will go to download the upper part of the. I will go here. Then we select this element. We go to export. We go to STL. And ready to download. I will change the name because if not, they will stop. Okay. Okay. Mhm. Mhm. We have it here, the two elements, the shell and also the top. Mhm. Ready to print. Then the last part should be using whatever of the 3D models we use for 3D printing software to print. For example, in my case, I can use, for example, Simplify or Creality Slicer. Go Creality. My printer name is Creality. And we will load the files to print from Creality. If I don't mind. We have it here. The base of the element. I will remove. Then let's go to File, Import Model, Discovery. I will chart 2. We have here our two elements for that. Ready to print. With this, we just need to prepare to print. As should be the simulation or printing. If we go here, we can see how the printer with the noodle start to create the file The moment that printer will start to prepare the parts at the end, finishing. We can see here how the system prepare with different support elements that we need in the way to have the shell ready to do. We can show here these areas are supports that we need to remove previously after the development that was created to support the topping of the parts on that. And okay, guys, that I think from my side is all. I hope you enjoy with the development. I hope you enjoy with this class related to develop the social distance device. Thank you very much to be here. See you. Regards from Spain.